Hello and welcome. This is Rashid Khan and you're watching my YouTube channel. In this video, I'll go through the main areas that you will need to know from the topic called radioactivity. The first one that you will need to know is the atomic models. Second is the structure of an atom. Number 3, you will need to know about background radiation. Number 4, you will need to know about types of radiations plus their properties. Number 5, you will need to know about decay equations. Number 6, you will need to know about the concept of half-life. 7, you will need to know about uses and dangers of radiation. And the last one is nuclear energy. I can't go through all of this, but there are a few bits which are very important, and I'll just quickly go through them with you. So when it comes to the structure of an atom, you'll need to know it contains positive nucleus. Now this positive nucleus is at the center of the atom. Then there are electrons which are negative, and they are found in energy shells around nucleus. You will need to know about background radiation. When it comes to the background radiation, you will need to know about sources, or the sources of background radiation. When it comes to this, you can say there are natural sources of background radiation, and then there are man-made. For example, when it comes to the natural ones, you can say from stars, from space, from radioactive rocks. When it comes to the man-made, we can say nuclear power plants, hospitals, and etc. When it comes to type of radiations and their properties, we generally have mainly 3 types, right? We've got alpha, which has a mass of 4 and a charge of 2. It is helium nucleus 1. Then we have beta, which is fast moving electron, has a mass of 0 and a charge of -1. This is fast moving electron. And the last one is gamma, which is 0, and 0 has no mass and no charge, and it is EM wave. You need to know alpha is least penetrating, but it is most ionizing. When it comes to gamma, it is most penetrating and least ionizing. So you need to know that alpha is stopped by the piece of paper, whereas gamma is stopped by a thick sheet of lead. When it comes to decay equations, you will need to know you will have a starting nucleus. I can say you will have X, you will have numbers here, this will change into Y, you will have some numbers here, and it will give out some sort of radiation, and this radiation will have 2 numbers. Now this radiation in the box will be either alpha, beta, or gamma. You need to remember the sum of the top 2 numbers on the right side must be equal to the total top number on the left side. Same, the sum of total bottom numbers on the right side must be equal to the total on the left side. So we say in a nuclear decay, mass is conserved and charge is conserved. So here I can say mass is conserved 1 and charge is conserved. I'm just going to make it up now, right? So for example, let's say we've been given two numbers. Here it is 57, here it is 25. And it gives out alpha radiation, which is 4, 2. They'll ask you to find these two numbers out. So I can do 57, take away 4 will give me 53. Now if you look, 53 add 4 will give you 57. So the total on the right side is same as the total on the left. Here is 25. Out of this 25, 2 is gone. I'm left with 23. Now if you add the bottom numbers together, you will see they will add up to 25. Next bit that you need to know is half-life. Remember, half-life is time taken for activity to reduce by 50%. The unit of half-life is always going to be the unit of time. It could be seconds, could be minutes, could be hours, days, weeks, years, and so on. In addition to this, you need to know the unit for activity is, so you used becquerels to measure it. When it comes to uses and dangers of radiations, you'll have to make use of these properties and you'll have to discuss them in your answer. Lastly, there is about nuclear energy. You need to remember, for the nuclear energy, there are two ways we can use this energy. One is called fission and the other one is called fusion. This one requires very high temperature and very high pressure. You can say these are called extreme conditions. Fission will require slow moving neutron. Okay, this word is important. Then you will also need to know about nuclear reactor. In nuclear reactor, mainly three type of questions can be asked. They'll ask you about what is the job of moderator. What is the job of boron rods? Okay, so we can say moderator, the job of the moderator is to slow down neutrons so that fission can take place. The job of the boron rods is to absorb neutrons. The reaction can be controlled. This is all from this topic, which I believe is the most important, and you must all know this, and it will be very useful while you're doing exam and answering questions related to this topic. I hope you'll find this video useful. I wish you all very good luck with your exam preparation. Thank you.